All right, hello. How you doing? Uh, another afternoon. We got another troubleshooting lab right here. We have three networks here, two routers, two PCs. Our goal right now is to have PC zero communicate with PC one, and the whole premise of this lab is about just routing, straight up routing. Um, Routing is essentially the best path for data to travel to, the best path, the most efficient path that routers do on layer three. Okay? And there's different types of it, or there's only two types. Typically, static routes and dynamic ones. Statics are fixed routes that network engineers that manually configure, or administrators as well. Dynamic ones are ones that are done by protocols, and they're done by protocols and auto learned and updated um, as the network changes. So that's about it. But today we're really just working with static routes, right? So first things first, where I would say, I already know, but it's if we try to ping the other PC, it's not gonna work. So this one is gonna be dot two. It's not, and the main reason why is first of all, it's not already set, but generally we're gonna be trying to have PC zero ping to this one, to our PC. This is gonna be 0.2 with the network. This is gonna be so very good question. Press this timing out. I'm gonna press C because we're gonna need to configure. So that's the IP config static. So we're gonna give this the IP address 192.168.0.2. Also, the reason why we're giving it 2 is because the interface on router 0 and the interface on router 1 is gonna be dot 1, which is the default gateway that we're gonna be using. And the main reason why we even have a default gateway, and this feels actually very important because if you don't have this, this is not gonna work. Um, the router is gonna realize that the IP address, like instance, right, where we're trying to ping 100.2, it's gonna notice that it's not in our subnet or in our network, and it's gonna try to route it out of the net. And this is where the gateway address comes to play, right? Because it's the basic way I would also like explain this is that if you're trying to send a letter to someone else, right, and you have like a mailbox, that's the gateway, right? You're trying to send that letter to another area that is obviously not within your reach, right? And the mo or post office man, or I don't know how you call it. I'm forgetting. Essentially, that person is the router. It's gonna go and route your letter to the actual home that you're trying. That's why we have home addresses and stuff like that. This one, PC one, also got this two. Film Masters also does it automatically for you. Fine. So, right off the bat, by this theory, we should be able to ping router zero because we should be able to our our gateway IP config our gateways. This is the same thing for because this right here is all Windows. Um, this right here is Windows, right? The compliance right because I'm nosing it. This one are actually just like its own Cisco. So now this can communicate to that. To minimize both of these are both set up. We're gonna actually put and actually mark them, mark this down. Easier. That's done now. We're gonna route a zero, and we're gonna actually just go in and check the running config. So, guessing by the 000 gig interface, that one should be set up properly. So, because we were able to ping our default gateway, this one also has this other interface that's connected to the router one set properly as well. Yep, 255.255.252. So, let's go check router one. Enable shortcut. This one router but doesn't have an IP address, so we're interface, or actually conft interface get 001 IP add and to shut down, which obviously always do memory. Now I should be able to other router with router one because we're in router one right now. There you go. First one's gonna fail. Okay, that's just how simulation works. But again, so now these two can communicate. Now it's actually good. If we go back to router 0, and we're trying to go ahead and ping the other PC one, it's not going to work. Usually it's instant, right? It's very instant, and it's taking its time. That's how you know, right? It's actually not going to work right off the bat. But 0%. The main reason why is because we don't have have it configured the static route. So just the IP route, which is this command, is very simple, very easy. This IP route and with the syntax of destination right here, the subnet mask right here, and then the next hop. Okay, this is essentially how it is. To break it down even further, right? So, I'm gonna text thing. Could actually copy it, but I think I wanted you to take this idea, just probably take it into like concept. So let's say this is you, this is you, this is you, or this is you, and we have let's like this is the destination. This destination. This destination that you're trying to, and this this is you. And along this path, we have multiple stops, multiple steps, multiple steps that will hit or get to that destination. This is pretty much the same. This whole command, if I want you to think about it as like a step mechanism, right? So in the process, we have 1, 2, 3 until we get to the end result is finishing all our steps, right? I want you to think that pre-route is the same, right? So first of all, we have to go to this stopping point, this step right here, right? And then we gotta go to this step, or this next step. I'm having a tongue twist right here. uh, we have this step 1 right here, and then we have step 2, and then we have to do, and this is all part of a process, and then step 3, which is the finish line, or the main goal, or whatever. This could also be like, let's say DoorDash, for example, Double Dash. Let's say you have that driver, wherever the driver's at, right? They have to go to, you pick up the order for restaurant. They probably pick up the order for another restaurant, right? And then get to your place where you're at. That's basically the same concept. And in general process, there's obviously steps to doing it, and once you're done, you have the end result. Same thing, right? But in terms of technology, in terms of actually all of this, Cisco packet traces, right? Our destination is essentially the subnet that we're trying to get to, right? Or yeah, well, the network we're trying to get to into, and the next step right here, right? Next step, the next step right here is essentially, or the next hop is essentially that's the next step. So if the data packet is right here, data packet is right here, and we're sending it to this router, right? What is the next step that this router should take this data packet to? This one, and that's essentially what, or this one, and that's essentially what next hop. Really bad drawing. That's essentially what next hop is. Next hop, basically the steps, the next step to the process of actually delivering that packet. And this whole idea is basically creating like technology, basically creating like instructional steps in the process to actually deliver something. So first do this, then do that, then do this, and then the end result is that. Right? Um, and let's go back to and essentially, if I were to explain it in this case, so IP route, right? Destination, which is gonna be the network address, right, of the other network, 192.168.100.0, and then it's subnet mask, which we already know is slash 24. Next hop would be to talk to router one, because we're doing this and we're doing this in router zero, so it will be 10.10.10.2, right? And we have to do this vice versa because if we go back to this, we also if we were starting from here, right? If we started from here, right? Start from here, we also got to do the same steps. It's the same path, the same distance, same thing, vice versa, right? So if you wanted to, we will have to do the same thing. So essentially, IP route 2.168 dot 0.0, right? 255.255.255 0. 10.10.10.1, which is router 0. And this command is done in router 1. First one is done in router 1. Second one is um well, the first one, sorry, is done on router 0, right? And configuring it. The second one is done in router 1, right? So let's actually do this. Router 0, um, configure terminal, IP route, 0, 2, 2, right? Done. N, right? And memory, see the config. So now any packet that, so now if we're trying to get to this subnet, for example, for this network, I keep saying subnet. If we're trying to get to this network, any IP address that actually is in this, forward it to the router. That's basically what it's trying to explain. And that's what the actual reason why dot zero is here. Is basically any address within this. So starting from 0 to 255, or any of the usable ones. So in this case, or 1 to 254, any of the usable. Um, it's going to be sent to router 1. That's it. That's basically the whole concept of IP route and the whole routing in general. And this is only static routing. Dynamic is something different, but we're focused on static. So let's do this for router. T. That's dot 0 10 10 So that's done. We go and memory. IP routes right here. So any address within this network is going to be forwarded to this router, router 0, from router 1's perspective. Now, in theory, close router 1, I can go and ping the PC1 from here. It should work. First one fails, rest is successful. There we go. And same thing on router 1, right? Go ahead and ping the other PC 192.168.0.2 successful. And just like that, well, and with this theory, also this theory, right? Because the actual mission was actually having PC talk to PC1, I should be able to ping the other computer. And just like that. And for visual stakes, sorry. I'm going to do this one more time. As you can see, the ladder is going to the router. Router 1. Straight to PC. I'm going to fast forward this a little bit. Check mark. There we go. That's a successful ping. That's really just about it. I'm going to update this. So remember, we added an IP address on gig interface for router 1, and added static routes to both routers. So, both net. All right, that's about it. So, if you are learning this right now, and you're actually just going to find an answer, I really advise you do. I try to understand this. It's not really that complex. It's actually really simple, but generally this is how this lab is done. Okay. Yeah. Have a good day.